Okay, find a place and sit down now, please. Okay. I have only 1 hour today. Okay. Now find a place quickly. Don't just stand there. Okay. There are a lot of seats in there. Come on, come on, come on, come on. Wait, you too, quickly. Okay, we'll start. I have been teaching you for 8 hours on a very big topic. You see, I have to simplify a lot of the things and managed to have delivered 3 topics to you. Okay, so as you can see from my file, topic 1 was on weaving and fabric. Okay, I introduced the basic principles of weaving to you. Okay, and also we talked about the fabric features and so on. Okay, and also classification of fabrics. Okay, and also how a weaving machine or a loom is working to produce fabrics. Remember the 5 motions I talked to you. Okay, of a loom to produce fabrics, which are the shedding, weft insertion, beat up, take up, and let off. Okay, so those are all covered in topic 1. And then in topic 2, I talked to you regarding the basic structures of woven fabrics, the elementary types of fabric structures, okay, including plain, twills, and satin and sateen. Okay, and we learned how to represent weaves on weave design paper. We also discussed the relationship between fabric structure and mechanical properties. Remember those that diagram with 3 curves in there, and we related that to 3 particular fabric structures. Okay, remember the computer generated the 3 structures there we used. Okay, so that's the second topic, structure and performance. And then on to the third topic, that's the variation of weaves. Okay, there are so many weaves. We'll have to learn some. Okay, we can't just say, we know the names without knowing some details. Okay, in a very simplified way, I talked about how to create new weaves from the plain, okay, to create plain derivatives, and also explained how to create twill derivatives using 2 particular techniques, which are the mirroring technique and the inverse mirroring technique. I remember I did mention, and for the other type of weaves, it might be too simple to set as questions, as examination questions, but I think the use of the 2 techniques, mirroring and the inverse mirroring, those are quite relevant. Okay, those are quite relevant. Those are the things I covered within the 8 hours this semester. Okay, so what I plan to do today is to talk about this. Okay, the formative questions and answers. The school wants us to do these sort of things. Okay, to give you further guidance, to enhance your understanding. Okay, I have uploaded this file onto Blackboard. Okay. You will be able to find it in my folder. The first file will be this one. Okay, so you will be able to find it. Right. Okay. So I have listed this many formative questions. Okay. So the first one is in what ways woven fabric are different from the knitted fabrics. Okay. This just help you to think. Second one, explain the basic features of woven fabrics for fashion applications. Okay? Third one, explain the relationship between structure and the behavior of woven fabrics. While you're looking at this, okay, I'm sure you're thinking, so can I answer this question? I think you can. Okay, all the questions you can answer. It's no problem. Okay. Fourth one, how does the weaving machine or a loom work to produce the woven fabrics? 5 motions there, isn't it? Yeah. Then how different structure patterns can be created through weaving. Okay, different structures. Then we make use of the shedding mechanisms. You know, different type of shedding mechanisms would be related to different structures. And then explain the way a colored pattern is produced through weaving. Okay, so we pattern the warp yarns, then we can pattern the weft yarns as well during weaving, and then we can have colored fabrics, colored woven fabrics. Okay, so that's the that one. And then the next question is classify the weaves used in woven fabrics. Okay, the weaves, weave classification, we've done that. Elementary weave, derivative weave, elementary weaves, derivative weaves, combined weaves, and compound weaves. We didn't have time to do anything for combined weave and a compound weave, but we did do something, okay, for the other two. You know, for elementary weaves, we had a thorough study, okay. For derivative weaves, we learned how to generate, in principle, how to generate plain derivatives from the plain weave using extension principle and using the plain weave logic principle. We talked about those. We didn't do practice, but we did talk about those. And for the twill, okay, I mentioned there are many different methods that can be used to create new weaves from twill, but we concentrated, again, so we concentrated on the use of a mirroring technique and a inverse mirroring technique. Okay, that's the classification. And then what are the elementary weaves and what are their features? Okay, so of course we know this now. And I have detailed things. I'm just read the questions. Okay, then how weaves are presented, okay, using the weave design paper. Of course we know, yeah? You should know. If you don't, then that's my failure, it would be. Then how can a new weave, how can new weaves be derived from the elementary weaves, which I just covered a moment ago? Explain how weave designs are used to guide the fabric production. You know, we in doing the weave structures, we do it on paper or on the screen of computer. You know, how can we turn that into a real fabric? Okay, so I think I explained that as well. So I will, you know, there are more pages in there. I'll go into details. Then explain how weave design. Sorry, I just read that one, did I? The last one then. Try to be familiar with the use of mirroring and the inverse mirroring techniques for creating twill derivative weaves. Okay, I think I should have another one in the major part of my of this presentation. I have another one which is regarding the fabric fabric classification according to the 6 different criteria. Remember those? Raw material, color, weight, weave, application, and so on. Okay, those things. Right, then the answers to these questions is explained during this hour. I'll go through this with you. Okay, first of all, in what ways woven fabrics are different from knitted fabrics? Okay, so there are different things. They are different in many different aspects. Okay, so from the look, I'm sure you can tell what is woven, what is knitted. But you see, if you think about it, I tend to list the difference in these 4 different aspects. The first thing is we use different yarns. Okay, we use different yarns. For weaving, we tend to use thin, solid yarns. Okay, thin and solid yarns for making woven fabrics. Okay, because of the, you know, if you look under your trousers, if you look under your shirt, okay, or dress, then we cannot use pretty thicker yarns like we would use for jumpers. Okay, so fine and solid yarns for woven. Coarse means thick, coarse, and Is it this course? It's a different course. Okay, OARSE. Sorry, it's my fault. Change it to OARSE. Okay, coarse and soft yarns for knitted fabrics. That's from the yarns point of view. Then from the structure point of view, okay, so we use woven fabric is produced by using two sets of yarns to interlace to form a woven fabric. Okay, so we use warp yarn as one set, weft yarn as another set. These two sets of yarns interlace together to form the woven fabric, whereas the knitted fabrics are formed by yarn interlooping. Okay, one yarn, it could use just one yarn to produce loops, and then loops into loops, and then you will have your fabric, knitted fabric. Okay, there are, of course, different varieties, but basically they would use just one set of yarn to interloop, okay, to form the knitted fabric. That's from the structure point of view. Okay, then from the property point of view, okay, from our daily experience, we could understand this as well. Woven fabrics are more solid, okay, and the geometry of the fabric is more stable, okay, whereas the knitted fabric, okay, is more solid, more soft, and more flexible. Okay, the dimensional stability of knitted fabric would not be as good as the woven, but you see, they are flexible. They're more comfortable to touch. Okay, so therefore, for applications, you know, the woven fabrics are usually used for outer clothing, okay, whereas the knitted fabrics are mostly used for inner clothing applications, okay, because it's soft and you know, more comfortable to touch. I think these are the main things, main differences between woven and the knitted fabrics. Okay, that's that one. Second question is to explain the fabric features of woven fabrics for fashion applications. So the features of the woven fabrics. Well, you see, we mentioned some in the for answering the previous question as well. Woven fabrics are formed from two sets of yarns, using two sets of yarns, interlacing at 90 degrees perpendicularly. Okay, so the warp yarn, weft yarn, they are 90 degrees apart. The set of yarn along the length direction are the warp yarns, along the width direction are the weft yarns. Okay, so this is one of the features. Two sets of yarns interlacing at 90 degrees. Okay, another feature would be we use various weaves. Okay, we use different structures. Okay, plain twill, diamond, diaper, waved weave, herringbone. You know, so many names. Hope sacks, ribs, and so on. Okay, so various weaves can be applied to create fabrics with different structural and mechanical properties. You know, we use different structures for different purposes. Okay, we can make the fabric look differently. We can also change or influence the performance of the fabric. Okay, so this is structure, weave is the second feature for woven fabrics. Then the third one is that we can incorporate colored yarns into the fabric. So we can create colored patterns. Okay, colored patterns can be employed in warp and weft yarns for color effect of the fabric. Okay, so that's the third feature. Then the fourth feature is that we could use yarns of different thickness. Okay, some of the fabrics are really thin. Okay, like silk, like you know, this kind of fabrics is very thin. Some fabrics are pretty thick. You know, like this is winter. Some of the heavy coat, if you've got a coat made from wool, for example, you see the fabric would be much thicker. Okay, so we could use different yarns. Okay, yarns with a different thickness or fineness. Okay, so that's another feature. And then the last one I mentioned here is that the fabric can be made with the predetermined warp and weft densities. This is a very important feature. Okay, so we don't just simply interlace the two sets of yarns together, but we do have a requirement on the density, warp density and weft density. How closely we would weave the warp yarns together, how closely we would weave the weft yarns together. So those things are called the warp density and weft density respectively. Okay, the warp density is measured by the number of warp yarns packed within certain width of the fabric. Okay, usually 1 centimeter. Okay, number of warp ends per centimeter. That's the unit for warp density. For weft density, that would be the number of weft yarns or number of picks per centimeter. Okay, you might, during your reading, you might come across old units, okay, old-fashioned units, like number of ends per inch, number of picks per inch. Yeah, so it's a similar thing. You can convert easily. Okay, so then these 5 points would provide an answer to this question: the basic features of woven fabrics. Okay, so if you have questions like this, if you could expand your explanation around these 5 points, then I think that would be proper. Okay, on the relationship between structure and behavior of woven fabrics. Okay, so on this, okay, you may use the 8 by 8 sized plain twill setting picture. Use that example. During my talk, I used that many times. Okay, the fabric models are in blue and orange color. Okay, blue is one set of yarns, orange is another set. Okay, we had plain twill, plain 2 down twill, Z, and also 8 and satin. We used those, for example. I expanded the plain many times. Okay, I expanded the twill many times as well. Okay, eventually all these 3 weaves are made into 8 by 8 size, so that you can compare easily. Okay, you can use that if you need to. Okay, if you need to, very soon you might be going home, seeing your friends. If they ask you what's the difference between plain twill and satin, you could use that as well. Okay, so in those models, okay, the plain weave intersected 8 times. Yeah, intersected 8 times, twill 4 times, and satin twice. Yeah, so we mentioned that quite a number of times. Based on this, then you can proceed on to the following 2 points. Other conditions being the same. What does this mean? For making a fabric, you could use a different yarn thickness. Okay, you could use a different type of fibers for making the fabric. Now you see, when in this discussion, we only concentrate on the structure. That's what I say. The other conditions being the same. You use the same yarn, same raw material, same loom for making the fabric. Everything is the same, but the only difference is the structure. Okay, only difference of fabric is the structure. So other conditions being the same, then the plain fabric will give us the tightest structure. Okay, remember the waterproof of umbrella fabric. Okay, that's the tightest. Why tightest? Because it intersected many more times than the other weaves. Okay, then satin is the loosest. Okay, because it has the least number of intersection, whereas twill is in between. Remember this? Yeah. So this is the structural difference. Then another thing is that plain would have more crimp. Every yarn in the plain woven fabric will be most crimped. Okay, so it goes up and down. It's just like a wave like that. Whereas the yarns in satin crimped the least, okay, because it has a long float, very straight, and then have one crimp in there. Okay, again, the twill yarns are in between. Okay, so the extent of crimp for twill yarns is in between. So these structural differences will cause a lot of differences into the mechanical properties. Okay, so I think the rest, I'm not going to repeat the things I've talked to you already. Okay, explain the stress-strain curves. Remember that one, yeah? For the 3 typical fabrics. Okay, if you ask, anybody, not just the examination, it may or may not be there. Okay, if you want to explain the structure influence onto the mechanical properties, then this diagram, stress-strain diagram, would be a very good one. Okay, the plane at the bottom, twill in the middle. Okay, the setting on the top. Okay, so that's the stress, that's the strain. Why the shape is like that? Okay, so when you have the same stress, what happens? When you have the same strain, what happens? What do you need? Okay, so I'm sure you will be able to answer that question like that. Okay, so how does a weaving machine or a loom, okay, work to produce woven fabrics? I put the loom into the bracket. I just want people to know a weaving machine is also called a loom. Okay, so after studying a year here to get your degree in fashion retailing, in the school where textile is strong, okay, if you ask people, if you don't know what a loom is, then that will be a failure of mine. Okay, not yours, of mine. So I want you to know. Okay, a weaving machine is a loom. Okay, so how does a weaving machine work to produce woven fabrics? So to answer this type of questions, you need to mention the 5 motions. Okay, the 5 motions are shedding. What does shedding do? I'll give you all the information during my talk. Okay, during my lectures. So basically, the shedding opens the warp yarn sheet delivered from the weaver's beam, okay, into 2 levels to form a space ready to accept the weft yarn to be inserted. Okay, and of course, you see, for different weave structures, then the way of separating the warp yarn sheet, okay, will be different. Okay, so basically, shedding is the first one. You need to open the shed, and then secondly, you need to insert the weft yarn. Okay, weft insertion will be delivering a pick of weft yarn into the shed. Okay, and of course, if you want to go further, then there are many different ways to deliver a weft yarn. Traditionally, we use a shuttle. We could use a projectile. We could use a rapier. We could use water jet. We could use air jet. Okay. Right, that's the weft insertion. Once that yarn is inserted, okay, it is not as close as we want it to be in the fabric. Then we will have to push it to the place where we wanted it to be. Okay, therefore we have this bit up motion. Okay, bit up motion. Bit up motion will push the new pick of weft yarn into the fabric fail. Okay. Fail, I hope you still remember, when you're weaving, okay, we produce fabrics from yarn to fabric. There must be somewhere there is a joint point. On this side is the fabric, on the other side is the yarn. So that point is the fail, F-E-L-L, okay? So when the fabrics are produced, then we needed to take that away from the fail position so that we can give rooms for new fabric to be formed. Okay, so we need to pull the fabric forward, okay, and wind it up somewhere. Okay, so the pulling of the fabric, lulling, sorry. Change that lulling to pulling, P. Okay, yeah, I do make mistakes. 2 now. Take up, okay, is to pull the fabric away from the fail, okay? And the rate of pulling is very important. How fast you would pull the fabric, that's very important, okay? Because that determines the weft density of the fabric. In the fabric features, I did mention, we need to pay attention to the warp density, weft density, okay? Weft density is determined, is controlled by take-up rate, okay? If you take up more quickly, then you will have low weft density. If you take up more slowly, then you will have higher weft density. Then the 5th motion is a let off. Okay, let off refers to the releasing of warp yarn lengths from the weaver's beam. Okay, so the weaver's beam will turn to release warp yarns, because we produce fabric, we use warp yarn as well as we use weft yarn. So the yarns need to be delivered gradually from the weaver's beam, okay, so that we can form the fabric. So if you want to answer the question, on the most basic information as how a woven fabric is produced on the weaving machine, then this 5 motion would be the most important thing that you need to mention. Okay, So I hope everybody should be happy on this one now. How different structural patterns can be created through weaving. Okay, so that's shedding. If if people ask you, how can we achieve different structures? How can we have, particular pattern? Then we do that, through shedding mechanism, through the use of shedding mechanisms during weaving. Okay, then you should concentrate on shedding. For shedding, we have 4 different types. Okay, so we have the from simple to more complicated. Okay, so we have a crank shedding mechanism. Remember that, which can only control 2 heeled frames. Okay, in other words, you see it can only control 2 different types of warp yarns. When one type goes up, the other one will have to go down, or they swap position. That being the case, then this type of shedding mechanism can only be used for producing plain woven fabrics. Yeah. Then the second one is the tappet shedding mechanism. Okay, we use the cams. Remember, I think I drew cams somewhere on the board. We use the cams. We use the cam profile. Okay, I did mention I don't want you to be too technical on these sort of things, but you see, you need to remember, for this kind of shedding mechanism, you can control from 2 to 8 heeled frames. In other words, this kind of shedding mechanism allows maximum 8, okay, from 2 to 8 different types of warp yarns. Then this 8 different group of yarns can move, independently. Okay, so with this capability, then you see this kind of shedding mechanism is able to help us to produce fabrics with simple weaves, like plain, of course, we can do, twill we can do, okay, satin we can do, and probably some simple derivative weaves we can do as well. But you see, the fabric structures would be still on the simple side. Okay, then we have the Dobby shedding mechanism. Dobby shedding mechanism we can control from 2 to 36 nominally. Okay, 36 heeled frames. Okay, and then we could control up to 36 different groups of yarns. Then you see, we have more freedom to form different structures. Therefore, you see, most of the daily fabrics we use domestically and for clothing can be produced by this kind of shedding mechanisms. Okay, so that's the. This is why I mentioned a number of times the Dobby shedding mechanism is very versatile. It's very useful. It's very useful. You can do a lot of things with it. Okay, so that's the Dobby. And then the last one is the Jacquard shedding mechanism. Okay, Jacquard is very different from the first 3 because the first 3, when they separate the warp yarns, they have to use heeled frames. Okay, to control the yarns, to control the warp yarns in a collective fashion. Okay, in a collective fashion. Whereas Jacquard will be able to control the yarns individually. Okay. So according to how we control the Jacquard shedding mechanism, okay, it is capable of controlling from 2 to thousands of different warp yarns. Okay, 2, 6, 8, 8 is a typical number. Okay, so which we have used for a long time, but nowadays we can have multiples. We can do multiples of this. Okay, 2 times of 2, 6, 8, 8, 3 times, and so on. Depends on what we need. Okay, so therefore the Jacquard is the most powerful shedding mechanism. Okay, therefore we can use this shedding mechanism to weave very, very complicated patterns. Okay, did I mention the 5-pound notes? People are making that kind of patterns on the weaving machine. And also for 3D, for you, 3D may not be that important. You will be fashion people, okay? So I'm a technologist. 3D is more important to me. And the Jacquard is very important for making 3-dimensional textiles as well. Okay, so to answer this question, how different structural patterns can be created through weaving, and then you meant to talk about the 4 different types of shading mechanisms and their capability. 2 Hilda frames, 2 to 8, 2 to 36, 2 to 2688. These are the capabilities. Okay, the larger the number, the more powerful the shading mechanism can be in terms of making fabrics. Okay, so this one. Next question: explain the way a colored pattern is produced through weaving. Okay, so I'm not wearing my jacket, and I can't see a woven one apart from the shirt in there. Anyway, right. Okay, so to make a color patterned fabric, okay, we will have to use warp yarns, which are color patterned. Weft yarns are color patterned as well. Okay, and I don't think we spend too much time on this one. Basically, the warp pattern, the warp yarn pattern, is produced during the weaving preparation period, which we didn't cover. Okay, during the warping process, then you can arrange, red yarns, blue yarns, black yarns, whatever colors you see in a very good sequence, and then we will use that to achieve the final pattern. As for the weft pattern, okay, we do that during weaving. Okay, we have a weft insertion mechanism. Okay, so when we need to insert the weft yarn, then we could choose up to 8 different colors. Do I use the red color, or do I use the blue color or green color, whatever color? You could choose from there. Okay, so by doing that, you can have the weft pattern. When the warp yarn pattern meets the weft yarn pattern, then you will have the fabric pattern. Okay, so that would be basically what you should say. Because I don't talk too much on this one, probably there should be no question on this one. Okay, but you still need to understand it. We study here. We don't only study for examinations. We study for knowledge, don't we? Yes. Right. Then the classification of weaves used for woven fabrics. I'm sure you know this very well. Okay, so we have the elementary weaves, we have derivative weaves, we have combined weaves, we have compound weaves. Okay. As I mentioned at the beginning of this hour, we didn't have time to do anything on the combined weaves and the compound weaves, but we did do something for the elementary. Okay, we did most of the things in elementary weaves. Okay, we know how to create a plain woven, how to draw a plain woven fabric. We know how to create a twill structure. Okay, whether that is S twill or Z twill. Okay. We did practice during the class as well. Okay, so you should be able to do that if necessary. Okay, the setting, the specification of setting the satin is different from that for twills. Okay, so remember the M and N things. So I'm not going into the detail, but you see, I just want to remind you. Yeah, and the derivatives. This will be the 3rd time I'm saying this. Derivatives are created, by using some techniques. For plane, based on plane, we do extension. We can extend the plane wave in the length direction or width direction. Okay. For length direction, we have the warp rib. For width direction, we'll have the weft rib weaves. If we extend the plane wave in both warp and weft directions, we'll be having hopsack weaves. Okay. And then we could follow the plane wave logic as well. Okay, right. Come to the derivatives. We could, if you go to my lecture page, the PowerPoint page, particular page there, then you can see we have a lot of different methods, and we have different effects as well. But you see, time only allowed us to study the mirroring and inverse mirroring. So and then you can imagine I might give you something in there. Okay, right. And then combined, I only need you to understand that weaves. When we produce fabrics, you could use just one weave. Okay, you could use combination of weaves for different features. Okay, for different features. If you are looking for a different appearance of the fabric, when you put two very different weaves together, then you could get a feature of your desire. Okay, And then compound weaves, we could have more complicated ones like the pile, like a velvet, like a towel, okay, like a backed cloth, like different things. Okay, please refer to the lecture notes. Okay, so I can't repeat everything. On the lecture notes, more details are given in there. Okay, right. What are the elementary weaves? And what are their features? Okay, so I'll keep on repeating things. We know the elementary weaves. The elementary weaves are featured by having a single float in each. Another error. In each warp, not what. Okay, do the change. Please change. Okay, there. Yeah, warp. Is it P and T together? No, they're not together. What? I don't know what happened. Okay, so in each there will be a single float in each warp and weft yarns. Okay, we have 3 types. The plan. Okay, that's the feature for that is it has the most frequent interlacement. Okay, for satin and satins, it has the least interlacement. Okay, then twill. It's between the other two, between plan and, the number interlacement is between the plan and satins. Okay? Onto the features. Okay, so that's a plain woven fabric. It's a solid fabric with a solid fabric surfaces. It should look solid as well because you see it changes the yarns change side very frequently. So you would have a solid look. Okay. Twill is featured by twill lines, either in the Z direction or in the S direction. But satin, okay, you would have a smooth fabric surface or surfaces, top and bottom. Okay, and depending on the type of fibers you use, it could be shiny as well. Okay, if you use a continuous filament like silk, like a continuous polyester, nylon, and so on, then the fabric could be pretty shiny. Okay, that's the feature for the elementary. How weaves are presented using weave designing paper. Okay, so I think this is a new skill you picked up during the 8 hours. Okay, apart from being able to see the differences for 2D or 3D illustrations of woven fabrics, we learned how to use the weave design paper, which is a professional way of representing the weaves. Okay, so in there we understand that the rows and the columns for the weave design paper is grouped into an 8 by 8 fashion. Okay, every 8 you would have a thicker line. Every 8 you will have a thicker line in vertical direction as well as in the horizontal direction. Okay, then the columns in the gaps, the vertical columns represent the warp yarn. The horizontal rows, okay, represent the weft yarn. Then a little grid, okay, a little square grid, okay, represents the yarn crossover points. When 2 yarns meet, okay, then that would be represented by grid, okay. In the grid, if we put a mark, then that would indicate the warp yarn is over the weft yarn. If we leave it as blank, then that is the weft yarn over the warp yarn. Okay, so we know all these things now. How can new weaves be derived from the elementary weaves? Okay, how can new weaves be derived from the elementary weaves? Okay, so we worked on the plan. As I said, you see, we do the extension. We can do the extension in one way. We can do the extension in 2 ways. For one way, okay, we get the rib fabric, RIB, okay, the rib fabric. For doing it in 2 ways, we have the hop sack fabric, hop sack weaves, okay. Then we could also do the plain weave logic. We didn't practice on this one. I just talked, okay. So that's the plain weave logic. And then for twills, there are many different methods, okay, but we concentrated on the use of mirroring and inverse mirroring technique, So I hope you will be able to use the mirroring and the inverse mirroring very fluently. Okay, very fluently. Right. Then for the setting, we could create new weaves as well from there, but we didn't have time to do it. So you don't have to bother too much. I think the most important thing there probably is the point in the middle, the twill one. Okay. Planes are too simple. We didn't do anything about the setting, and then we only did something regarding the twill derivative. Okay. Right. And then mirroring and inverse mirroring technique. Okay, so what are they? What are they? For mirroring, okay, we can create waved weaves and diamond weaves. Okay, if you use the mirroring technique once, either in the horizontal direction or vertical direction, you could create horizontal waved weaves or vertical waved weaves. Okay, and if you do use the mirroring technique twice, then you would have the diamond weave. Okay. So what are involved in here? Well, one important thing there is actually to calculate the new weave repeat, which I didn't mention here because there are too many things already. You know, I asked you to refer to the lecture and the seminar notes. You know, after calculating the repeat, okay, then the important things are as follows. Okay, where do we put the mirror for using the mirroring technique? We place it on the last yarn. Okay, we place it on the last yarn, and then we will mirror copy the weave from one side, usually from from the left hand side onto the right hand side, if we are doing a horizontal one, or we mirror copy that from lower to upper half of the weave, if we are doing a vertical one. Okay, so that's a mirror copy. Mirror copy means, you see, whatever is on this side will be exactly on the other side. Okay, because a mirror, you know, if outside is you, then looking into the mirror it should be you as well. It's just the direction is opposite. Okay, right. So mirroring once, you have the waved weave. Mirroring twice, you have the diamond weave. Okay, so basically that's the mirroring technique. You need to do practice. Okay, so I'm just telling you about the principles again. For the inverse mirroring, okay, for the inverse mirroring, another I copied from, you know, when I was doing this, I copied from the first part. No, we should have change. Please change. Okay, we should have the herringbone weave and diaper weave. Okay, herringbone and diaper. I'm sure you know this. Okay, right. Okay, so this is the fourth mistake, I think, already. Right? Okay. What are involved in this? Okay, we need to calculate the repeat first. Once the repeats are calculated, okay, make sure that you will be using the borderline of the last yarn, for the last yarn, to place the mirror. Okay, you don't place the mirror, you don't place the inverse mirror on the yarn, but you place the mirror on the line after the last yarn. Yeah? Okay, so that's that. And then we inverse mirror copy the weave from one side to the other side. Okay, maybe from left to the right hand side, maybe from lower to upper. Okay, then inverse mirroring once you will have sorry about this. Okay, you will have the herringbone weave. You know, I just copied from there, and then this is what happened. You will have the herringbone weave. Okay, twice you will have the diaper weave. Okay, so please correct now. Okay, don't just say Dr. Chen said mirroring, inverse mirroring, they gave us the same weave. No, it's just yeah. Okay, the good thing I said is refer to the lecture and the seminar notes. I think the information there is accurate. Okay, so explain, I think this is the last one. Yes, that is the last one. Explain how weave designs are used to guide the fabric production. Okay, we have done the weaves. We could have a weave diagram, okay, on paper, on the screen. How do we turn that into real fabric? Okay, the weave, we need to understand the three things here. The first thing is the weave diagram. wave diagram represents the interlacement between warp and weft yarns. Okay? Then we have another diagram which is called draft. Draft shows how the warp ends and are drawn into the hild frames. Okay, so we have a hild frame 1, 2, 3, 4 in that way. Okay, then each of the yarns will have to be drawn into the hild frames. So draft shows how the yarns are drawn in there. And then we have a third diagram, which is a lifting plan. Okay, lifting plan is an indication, will indicate at each pick insertion. Okay, at each pick insertion, which hild frame must be lifted. Okay, must be lifted to form the shed. Sorry. To form the shed, not to form. There should be M in there, okay? To form the shed, okay? So when you're considering this particular pick to be inserted, okay? So which hild frame will be lifted, okay? So weave together with the draft can be used to derive the lifting plan, okay? So we have 3 diagrams. Knowing any 2 of them, you can work out the third. For production purposes, we have the wave diagram from design. We have the draft, from the, knowing the loom. And then wave and the draft working together, we can derive the lifting plan. I didn't spend time to tell you how to do that, but that is a possibility. You need to know. You need to know. Okay, so these are the formative questions. For the errors in there, when I go back to my office, I'll correct them and reload onto Blackboard so that the information on Blackboard will be absolutely correct. Okay? Right, that is the Q&A. Okay? Then a little bit on the examination. Okay, a little bit on the examination. For examination, for the assessment of this module, I'm sure Anura might have told you. Okay, 30% are for the coursework. You did it with Selena. Okay, and then 70% will be from the examinations. Okay, in the paper, there will be 2 sections. There'll be 2 sections. Okay, section A is woven structure. Section B is knitted structure. In each section, there'll be 2 questions. In my section A, woven structure, there are 2 questions in there. Okay, so altogether you have 4 questions, but you need only to answer 1 question from each section. Altogether you need only to answer 2 questions from 4. Okay, and the time you would have is 2 hours. Okay, so you would have plenty of time for answering the question. Okay, and then the next thing you might ask me, probably, Dr. Chen, what are your questions? that is the thing I cannot tell you. Okay. What I can tell you is, you see, for my questions, I have 2 parts in my question. Okay. Because we have quite a number of things there. I have 2 parts. Okay. But you see, if you have selected to answer one of my questions, both parts will have to be answered. Okay. Both parts will have to be answered. So some people have 3 parts, some people may have 4 parts, but I had 2. Okay, I have 2 for my questions. Okay, then what else? Do you have a question? No, let's do questions. Do you have questions? You can just yes, please. Well, what I can say is that if you can fully understand the questions are listed in here, okay, and expand the answer from this, you see mine is just bullet points. I don't want you to produce a bullet point for me. The answer to your question is, if you understand this, if you can expand it to a suitable length, I think you will be able to answer my questions. Okay. More questions? On Thursday, I'm going away. So during your revision period, you can't see me. Of course, you can send emails to me, but you will not be able to see me. So we have few minutes now. If you do have questions, please raise your hand and ask me. Are you all? Oh yes, there is one.
Do you have a word count?
A word? Not exactly. You know, when we are marking, we don't count the number of words. But basically, for descriptive questions, I think a page-ish would be fine. Yeah, a page, one page, but not double line, single spacing. Okay, and the word each letter should not be too big. Okay, yeah, you need to give the basic thing is you need to give us your understanding in proper detail. Okay, you can't just say a few words. Okay, so you want a page? I'll give you very big writing. Oh, that's one page. No, that will not do. Yes.
So you want a proper text then, and not just like bullet points or like.
Yeah. Well, you see, maybe you have a guess that in my question there could be descriptive one, or there could be diagram sort of things to draw. Yeah. So if it is a descriptive one, I don't prefer you give me the bullet points. Okay. Because if you give me the bullet points, you could just say, "Oh, I'll mention this point," but you see, you may not be able to explain it further. Okay? Yes. Yeah. If you give me bullet points and then explain to produce a big block of then that should be fine. That should be fine. I'm not just. I think when people ask me how long the answer should be, I think a page-ish would be fine. Okay? Yeah, maybe more, maybe slightly less. And then the most important thing is your answer should cover the points, should reflect your understanding. That's the main thing. Yeah. Yes. Yeah. I said in my questions I have two parts. Yeah. On this side, do you have questions? Do you? You don't? Are you all happy? Are you all happy? Very good. Okay. So with that, this will be my my part of the teaching. So I wish you all the best for your examination, and probably Merry Christmas. Anura will be here for the next hour. Can I just add, if you have questions regarding the examination during the revision period, remember the two TAs, okay? So you may contact them for help, and if you need my help, then I can offer my help to you through email. You can send me email. If I have time, I will answer I will find the time to answer your questions. Okay? Yeah. the revision lecture. Don't go away. I didn't mention that, okay? So I will do the first hour and you're doing the second one. So don't go.
All right. So we are doing the revision class today first, and afterwards, if we have any time left, we can look at the remaining slides, right? I think during my last lectures, I think I completed this. I think in this class I was able to only complete the first chapter and the second chapter, right? And then in the seminar classes you all covered all three, right? Introduction to weft and warp knitting, graphical representation, and then garment manufacturing, right? Now in graphical representation, as I can remember, I went through all the structures, right? I remember it as that I went through all these structures, right? And then I talked about this as well, and I told that these are Doyle's empirical results from his experiments, and then Munden's experimental results. I said that they are considered as important discoveries in knitting, right? So generally these two information in these two slides are taught in knitting lectures. Still you can see that there's a certain there's a logical relationship in there when the stitch density is proportional to the reciprocal of stitch length. That means whenever the stitch length increases, stitch density decreases. That is readily understandable, right? I think so, right? I think probably I drew this as well and explained. So stitch density is the number of stitches in a unit area, right? So if we say this is a unit area, you can't see? Right. Say if this is a unit area, right, what it means is if the stitch length, now stitch length is knitted stitch, so from here to here the length of yarn in the knitted stitch, that is the stitch length, right? What this means is if the stitch length is smaller, that means if the stitch size is smaller, then we can fit more stitches in here. Right? If stitch length is longer, only a few stitches can be fitted here, right? So that's the same thing that it says. So that relationship is what is said here. So that is logical, right? So stitch density is proportional to the 1 over stitch length, right? The important part is it says that independent of other manufacturing factors. So it is independent of, say, any yarn tension or any other manufacturing factors. Okay. Then after that, I think I went through this as well. Here CPI means courses per inch, right? hope you can read this. Can you? So courses per inch is CPI. So courses per inch is proportional to 1 over stitch length. Again, what it means is, if the stitch length decreases, courses per inch increases. WPI means wales per inch. Right? So wales per inch has the same relationship. Right? So what it means is, say if the stitch length is smaller, so you can fit more like this, and we'll say more courses, right? If the stitch length is smaller, we can actually fit more courses in them, right? So there are courses per inch. If the stitch length is smaller, more courses can be fitted. In the same way, if the stitch length is smaller, we can fit more wales in it, right? So again, the relationship is logical, right? However, what he found out was that when he did the experiments, see that proportionality mark there. The proportionality mark is actually drawn like this. Okay? So whenever we want to get rid of the proportionality mark, we have to multiply it by a constant value. That's a mathematical thing. Okay? Whenever we want to get rid of the proportionality mark and express it as an equation, we need to multiply it by a constant. So in the first equation, courses per inch equals Kc divided by stitch length. Again, this is what is written there, right? And Kc is the constant. LST means stitch length, right? So we multiply it by a constant, right? And then the same thing for the wales per inch. So these are the two equations we have, right? So his finding is that values for Kc in that equation, values for Kc, it keeps on varying between 5 and 5.3. And Kw varies between 3.8 and 5.1. Right? So this is what he found from his experimental studies. And depending on that, he defined a parameter called stitch shape factor, which is Kc divided by Kw. Right? So these are the findings, so which we are required to remember. Generally, it is well difficult to ask questions from this. This is some theory, well, not theory. It is some empirical information from experiments. We can see, we can understand it that there's a logical relationship and it is that logical relationship that is shown there. However, at the same time, we get these values as well, and the statement in the previous slide which says that the relationship is actually independent of any knitting parameters, right? So these are some information that we need to remember. And then I can't remember whether I went to these slides, right? So then there's another couple of definitions that we need to go through. One is cover factor. Cover factor of a fabric is defined as the fraction of space occupied by the yarn. So if you take this rectangular area, so this is the middle of this feet, so single loop or feet of this loop to the middle here, and if you select a single stitch, single knitted stitch, right, the cover factor is defined the space occupied by the yarn divided by the space occupied by the stitch. So the space occupied by the stitch is this rectangular area. Space occupied by the yarn is wherever this purple colored yarn is, that is the space occupied by the yarn, right? So what it means is, if you look at that rectangular area, any area which is not covered by the yarn is the empty space, right? And the area covered by the yarn is the component that goes to the top here, right? This is the area covered by the yarn, and this is the rectangular area, right? So it is given as a fraction just to see how open the structure is, or how porous the structure is. Okay? Then there are some more definitions relating to this area. Now, the cover factor, the term cover factor is more related to weaving, right? So the parameter that is more used together with knitting or knitted fabrics is the tightness factor, the component what we call tightness factor. So it is given that cover factor is a multiplication of the tightness factor, right? So the value k can be anything. What it means again is that there's a relationship between cover factor and the tightness factor. Okay? And then the tightness factor is defined by this equation. Square root of yarn count in text divided by stitch length in centimeters or millimeters. So whenever stitch length is given in centimeters, that is expressed. That is said that we say that the tightness factor is this value, where the stitch length is measured in centimeters, or tightness factor is this value, where the stitch length is measured in millimeters. Okay? Everybody all right? These are equations that you are required to remember. Sorry? K is a constant value. It is some constant value. What it means is, say that again. No, again in here you just need to remember that there's a say direct relationship between the cover factor and the tightness factor. You won't be asked questions giving k value, what is the other value. these are just some theory you need to remember. Okay? Right. So I haven't actually asked any questions in the past regarding this, asking you to write these equations or giving one value and asking you to calculate the next value. But I always in the lectures I teach this because this is considered as content that should be taught to the students. Okay? So tightness factor again can be represented by this equation. Right? Now, how we use it, how we use the tightness factor value in knitting is, for knitted structures, it is recommended that the ideal tightness factor value is 14.6. Right? And then if it is below that, we consider the fabric is slack or loose fabric, more open fabric. Or if the tightness factor is above 14.6, we consider the fabric structure to be very tight fabric, less openings, right? And it is a tight fabric. Now in these cases, stitch length is measured in centimeters, right? So the tightness factor is somehow calculated using this equation, where the stitch length is measured in centimeters, right? And this is the relationship which says with the knitted structure is too slack, too tight structure, or the correct tightness in the structure. Okay? Again, these are findings. Two fabrics knitted with the same tightness factor will be the same, so that tightness wise they are the same. If the tightness factor is high, then the knitted structure will be stiff and rigid. That means it doesn't bend easily. It doesn't drape well. It is stiffer fabric. If the tightness factor is low, then the knitted structure will be slack. So it will drape very easily over a three-dimensional object. If the tightness factor is low, fabric can bend very easily. Okay? So in that presentation, those are the slides that I couldn't go through last time, I think, right? Are there any questions from them? Yeah.
Okay. So I'm confused because this is the revision lecture, right?
Sorry?
It's the revision lecture, right?
Oh no, I remember last time I told that there's few slides remaining. I will finish them and then I'll go to the revision.
Okay.
Right?
Yeah.
Okay.
That's really good.
Right. So, so the revision wise, so if you don't have any questions now, right? The revision wise, the sections that I need to go through from the sections that I taught you, right, are the two chapters. The one is actually this introduction to weft knitting, okay, and the second one is the yarn path notations, right? You have actually gone through seminars in this area as well, and you have actually looked at past questions and answers to them. Okay? Now, generally in the past papers, I'll go through these slides briefly, and I'll explain what type of questions were asked in the past papers. You have gone through them as well. Some of the questions you have gone through as well with the seminar teaching assistants, right? In some questions, past questions, there were instances where I've asked about comparing wave knitted structures to woven structures, how they compare with each other, right? So where you would have to actually mention about the loop structure of knitted fabrics and then the straight yarn structure of woven fabrics, right? And whenever we actually stretch them in either direction, in the wave direction, warp direction, what happens to them? And then the comparing it depending on the say load that is or force that is necessary to stretch them. Explaining that loop structure, whenever we apply a force initially, we only need to unbend the loops, which takes a lower force, compared to straight yarn structures. Where woven structures, we have straight yarn. Whenever we apply a force that in either direction, warp direction or wave direction, that it is difficult to stretch because the yarn are straight. There's undulations, yarn going up and down, but that is a very small deformation, right? So along those lines, explaining the differences between the weft knitted structures and woven structures. So there are questions in that area. Then I also went through this slide. So the answers that is expected from you is only introductory answers. Wherever you answer questions, you can actually draw sketches and answer them as well. So drawing the sketches wherever you can is part of the answer. Again, these are presented wave knitted structures and the warp knitted structures. It was pointed out to you how both are loop structures. Both have their say what we can expect from a loop structure, the openness of the structure, fluid flow through the structure. There are certain properties that we discussed, and both have them. However, here the yarn flow direction is in the weft direction. Here the yarn flow direction is in the warp direction. And again, I discussed about that it's generally easier to stretch the weft knitted structure than warp knitted structure because of larger contact areas, yarn to yarn contact areas, right? So along those lines, you are expected to describe this and differentiate between these. Applications, there were past question papers where you were asked to actually describe various applications, right? So whenever you compare the weft knitted structures, warp knitted structures, the applications can be given as well as differences between these two structures. Characteristics of knitted structures. There were past questions on this, right? So the knitted structures are open structures. There are stretch properties because of the looped structure there. Again, because of it's a loop structure, it is not tightly dense yarn that you find in the knitted structures. Because of that, it is easy for it to drape as well. The yarn doesn't have an exact direction because of the loops, so that helps the fabric to drape over a three-dimensional object. So about those things you can comment. Ability to engineer thermal and fluid transfer properties. I think I described those during the lectures, right? So because you have a say open structure, it is possible for warmer air to pass through them. At the same time, these loops actually function as the pockets inside which warmer air can be maintained, right? The loop structure is a resistance. There's a certain resistance to the flow. So because of that, it can hold a certain amount of warm air next to the body in the loop structure. But at the same time, they are good at, say, absorbing, sweat, moisture, and then bringing it to the surface where it can evaporate. So those properties are again in some of the past questions they were asked. Then sometimes in the past questions there's questions asking you to define terminology, various terminology, right? So things like this could be asked. Define knitted loops, define yarn loops, define knitted stitches. So those could be asked. Okay. So whenever you are, if a question like this comes, you can always sketch these structures and then point them and describe. If you draw any sketches, it is easier for you to remember as well, right? So if you are asked to actually define what a knitted stitch is, what is a knitted veil, what is a knitted course, you should be able to describe them. Wherever you find it difficult to describe, draw a sketch and then describe that as far as you can. And these are all terminology we use: heads of loops, legs, feet of the loops, right? Then we talked about the normal loop, the feel of a knitted loop, right? On the face side, reverse side. So face side to touch what it feels like in a knitted fabric. If a knitted fabric has a face side and a reverse side, one way you can actually identify without looking at it, or if the stitches are too small, is there's a smooth side and a rough side, right? So that is because of the longer yarn elements in the face side, and then the heads and feet on the reverse side, which are more rougher to the touch. So there are questions. There were questions in the past asking about them. Then basic fabric structures, you need to know them. You need to be able to define them. You need to be able to give a small description of them, characteristics of them, right? And you should be able to draw the yarn path notations of them as well, right? You learned that during the class, right? Okay, right? So you are expected to be able to do that. Okay. So if you are asked about applications of them, most of these structures are actually used in garments, right? Plain knitted structures are used in garments. Pearl knitted structures are used in garments, say pullovers, cardigans, in those. Rib structures are used in the cuff of the sleeve or the bottom of the panels, front panels, back panels of, pullovers. Rib structures are used in hats, right? So like that you can actually give different applications where they can be used. Interlock structures can be used as well in garments. However, interlock structures take a longer time to knit, but still it has a different effect because it gives a certain stiffness to the fabric. right? So this part is actually on the characteristics or properties of the basic knitted structures, right? All this is about. Thereafter we come to the binding elements, right? So you need to know about the binding elements. What are the binding elements? So stitches, knitted stitches, which is the primary binding element, and then float stitches, tuck stitches, and selvage stitches, right? You should be able to sketch them, and based on the sketches you should be able to say explain what they are, their behavior, right? So whenever you describe about, say, float stitches, tuck stitches, you would need to describe the held loops. So in the location where the float stitches or tuck stitches are, what happens to the structure if we try to deform it? You should be clear on that, so how they would behave. And you should be able to actually talk about the limitations to the use of them. So along a course, how many or approximately how far we can use them, how many of them we can use them, or what is the limitation, and if we exceed that limitation, what happens to the knitted structure, things like that you should be able to say write about. And in the same way, if the float stitches are continued or tuck stitches are continued in the veil direction consecutively, what happens? So you know that the held loop will keep on elongating. So at one point the held loop will break, at which time the fabric will have a defect, right? So you should be able to describe these things along these lines. Okay. And then you should be able to describe about the selvage stitches as well. Are there any sections in this which you found it difficult to understand? I think both the first two chapters, I think even the garment manufacturing it's not that difficult. Oh, it's not difficult at all, I think, right? So, okay, about this chapter, what do you think? Are there any difficult parts? I think the questions that are asked at the exam, generally they are direct questions. Most of them, the answers are in these handouts, right? So the minimum answer you can give from the information in the handout. Now, in the handbook, you have recommended text, recommended books, out of which the David Spencer's Knitting Technology book is a main textbook that you can read, which is available, say many copies of that is available in the library. I think you can actually download chapters of it from the library as well, right? It is also available in the internet as far as I know. Okay? So the minimum answers to any question can be given from the information in the handouts. The rest of the information, it is possible to actually get them from the recommended texts. There's something which I plan to do. I have some files that I think I haven't actually these files. These PDF files, I'll send them to you by email. I'll send them to you today. Okay. So they are actually extracts from different books, from David Spencer's book, and then a couple of other books. uh, there are extracts from those books, so that without reading the whole book, you can actually get more information in the area that we went through. Right? So I'll email this to you. Okay. Are there any other questions? Are there any other questions? One moment, please. Okay. Yeah. So at that time, I didn't know that during the seminars, you all have covered that area. Then later I found out that you all have covered the area. Usually, the university's rule is that anything that is taught during the class, during the lectures, anything taught during the seminar classes, or anything you learn from lab classes can be in the exam. Now, I didn't have any lab classes, right? For knitting, there were no lab classes. So, theoretically, questions could be asked from the 2 chapters I taught you, and anything that was taught in the seminar classes. So, from both of them, you could get questions. Yeah?
Okay, and since you just said that, all the formulas, they're not really.
Formulas means the last.
These things you just
Oh, these ones.
told us about because we have never had
It is very difficult to ask questions from this.
right? It's not that good, right?
It is, well, I can't relate it to.
Never practiced it and stuff, so I'm just wondering,
Right? So, I haven't asked, up to now, I haven't asked any questions from this area, because it is very difficult to ask any questions. I can, yeah. Right? Okay. Still, what you need to do, if you, it is just remembering it, that's all.
just for our own sake,
Yeah,
but
yeah.
not literally. Like,
Yeah,
not
okay.
necessarily.
It is difficult to actually give questions from that. Yeah. Anything else? Right? So we can go to the other presentation. Right? On yarn path notations, are there any questions from this section? So the major part of this is actually drawing the yarn path notations on point paper, right? So you could get questions from this part, or you may not get questions from this part. You know that for the exam paper, there's 2 questions from knitting, there's 2 questions from weaving. So they are actually divided as section A, section B. So you are expected to answer 1 question from section A, 1 question from section B, right? So that means you have to answer at least 1 knitting question and at least 1 weaving question. Not at least, actually 1. You can't answer 2 from each section, right? So, however, that means that you have a choice. You can select between from 2 questions. You can select 1 question for knitting and select 1 question from 2 in weaving. All right? Are you clear on now? If you need to draw yarn path notations, are you clear on which yarn path notation paper to use? Right? The easiest thing for you to do is, because you all only have 3 lectures for knitting, you all only have 3 lectures, right? And this is not your, okay, your major area is management, right? So because of that, this subject is taught in a way that you understand it easily. It's not made difficult. Like for say textile technology students. Okay. So whenever you draw these yarn path notations, something that you should remember is that only the yarn path notations that you are asked to or you are taught are questioned at the exam. Right? So if you remember which yarn path notation paper are used for each of the structures, then you couldn't go wrong. Right? Okay? So use the same yarn path notation paper that is used in these handouts. Same type of yarn path notation paper that is used in these handouts. Then you couldn't get the answers wrong. Even though each year I say this, every year there are certain number of students who use the wrong notation paper. Right? Because if you use the wrong notation paper for any questions where you are asked to draw yarn path notations, you would lose those marks. Okay? There are some questions in the past papers where you are asked to actually describe why yarn path notations are useful. What is the need for them? Right? And then again, certain yarn path notations, main yarn path notations. So knitted stitch on the front needle bed, knitted stitch on the back needle bed, tuck stitch on the front needle bed, tuck stitch on the back needle bed, float stitch on the front needle bed, float stitch on the back needle bed. Right? Things like that. Right? So probably I think you learnt about this in your seminar classes. Right? Right? Then there were some questions about low butt needles, high butt needles. You learnt about them as well, I think, during the seminar classes. And probably about somewhere some of these structures are used. Then after that, I think it is very rarely you are asked to explain how to knit certain structures. Now, plain knitted structure, it is very easy. It is just using a single needle bed, either the front needle bed or the back needle bed, and using that, creating loops on that needle bed. That's how you create the plain knitted structure. But knitted structures such as interlock structure, pearl knitted structure, there were some questions in the past where students were asked to explain how they are made. Right? Right. From this, because we have only a limited amount of time, from this presentation, what are the difficult areas? Is there anything that I should explain again? Remember, if you have any questions, you can email me and come and see me. It would help if you come with maybe 2 or 3 or few of you come together. Then I don't have to repeat the same thing again, right? But if you have any questions, send me an email and then come and see me. I try to help as best as I can. Okay? All right. Any questions from this part? I think these are easy, right? These are not difficult. As long as you remember, wherever there is certain information, characteristics of knitted structures or information about knitted structures, if you can remember them, then it is not difficult, because most of the questions are direct questions, right? Only only in garment manufacturing, certain practical questions could be asked, right? For example, in one of the past papers, there's a question about, say, usually there's a scenario where garment manufacturing company, which is actually based on cut and sew garment manufacturing technology. Cut and sew means you have flat fabric on which you actually draw the panel shapes, cut them, sew them together, and produce a garment. So in such a company, if the company wants to actually change their manufacturing methods, and they want to actually say either go towards higher technology or value-added technology, or change their manufacturing methods, like going to electronic flatbed knitting, what are the things to think about, right? Things like that. So on those lines, explaining some of these seminar classes should have actually discussed some of these. So things like, say, if you use electronic flatbed knitting machines, yarn wastage is minimized. In cut and sewing, there's yarn wastage. If you use electronic flatbed knitting machines, and if you use the fully fashioned panels, that means shaped panel knitting, right? Wastage is minimized. Then there's standardization, because the machine is handling the shapes. So there's standardization. All the garments are about the same size. You can use linking machines and things like that, which can actually reduce the seam sizes, so the garments would become more comfortable, right? Things like these are there, which are actually kind of general equations, right? So you are expected to know about them from the information that you learned. Okay? Any other questions? Do you have another lecture after this? We've been asked to actually always finish our lectures at 50 past, so that we give always 10 minutes for the students to go to their next lecture. If I am not allowed to actually go past 2:50, right? But since we don't have any more time, if you have any other questions, right, email me and come and see me.
Can we use pencil to do it?
Yeah, that's fine. Yeah. Oh, the lecturer has come. Shall we go outside and then ask? Hi.
Seem to have a room full of Chinese ladies here.
Yeah, 90% Chinese. Shall we go outside?